Kinematics 1D means the topic which you have studied previously, motion in a straight line. Yeah, right. So any motion that is in a straight line or 1D comes under kinematics 1D. So kinematics, so there are two branch of motion. One is kinematics, the other is dynamics. So kinematics is when you are studying any object, right? The motion of any object without looking into the cause or what are the forces that is causing that motion. It is known as kinematics. So you are not interested in the force that is causing the motion. Say a body accelerates at a speed of this, say 10 meter per second square, but you are not interested in what is causing that acceleration. Okay, so that branch is known as kinematics. Dynamics is when you are interested in the force that is causing the motion. Okay, say you have a machine. So that machine is operating or accelerating, or say the engine is, a car is accelerating at some speed. So the engine is the source of the acceleration, right? It is generating torque. So when you calculate that force, then that comes under dynamics. Okay, so 1D you'll be studying about motion in a straight line. Kinematics 2D you'll be studying about motion in a plane, and there you have this topic called projectile motion. Okay, I think you had shared a question on projectile motion previously, and we discussed the concept of range, right? Range and maximum height. Right, so again, from the perspective of JEE, both these topics are very important. So kinematics is the study of motion of objects without taking into account the factor which causes the motion. That is the nature of force. So we are not interested in the force. And what do you mean by motion? Motion means if a body is changing the position with time. Right, then only we say the body is in motion. Otherwise we say body is at rest. So when we say motion, there is one important concept of frame of reference. What do you mean by frame of reference? Yeah, very good. So I may be at rest, right? But if I'm standing in the moon, right? Or if someone is standing on the moon and observing me, I am moving with the speed in which the earth is moving. Right, so if we change the frame of reference, the object can be either at rest or in motion. Right, so it is very important to know what the frame of reference is before classifying anything under rest or in motion. Okay, so when we study the concept of relative velocity, so there also the frame of reference is very useful. Right, so motion is a combined property of the object under study and the observer. So this object under study is the object which we are observing. Observer is someone who observes. Right, so there is no meaning of rest or motion without the viewer. In other words, absolute motion or rest is meaningless. Absolute means it is at absolute rest. So something is in motion with respect to something else every time. Right, say a train is in motion with respect to an observer who is say in the platform, who is sitting in the platform. However, the train will not be moving with respect to a passenger who is in the train, because if you observe the train with respect to the passenger who is sitting inside the train, the velocity of the train is going to be zero, right? Because both are moving at the same speed. So the frame of reference is also moving. So there can be different types of frame of reference. So you can have a frame of reference that is at rest. You can have a frame of reference that is moving with a constant speed. You can also have a frame of reference that is accelerating. Okay, so frame of reference, when the frame of reference accelerates or moves, it becomes an important topic for JEE advanced, right? Mostly frame of reference, if you are changing the frame of reference, it is related to JEE means, but if say the frame of reference is accelerating, Then you can have some questions from advanced. Okay. So to locate the position of particle, we need a reference frame. A commonly used reference frame is Cartesian coordinate system or simply coordinate system, wherein we have the x, y, z, the positions of a particle. So note that we have x, y, z, all three coordinates, right? However, when we are studying kinematics 1D, only one of this is going to change, either x or y or z. Right, so the reference frame is chosen according to the problem, this we'll see. If the frame is not mentioned, then ground is taken as the reference frame. So most of the times, the frame of reference is not mentioned, so we take the ground as the reference frame. Now again, a very common explanation, what is the difference between distance and displacement? This you already know. So distance is the total path that you travel. For example, if you look at this, so a person traveled from A to B via C. So this is the distance, however, this is the displacement. The distance is the total path that one takes. Displacement is the shortest path between the initial and final position. So displacement only depends on the initial and the final position, whereas distance depends on the route. Okay. So for a moving body, distance can't have 0 or negative values, but displacement may be positive, negative or 0. Right, so displacement may be positive if the object is moving, right, say along a single direction. If it is coming back, then it can be negative, and it can be 0 when the initial point and the final point is the same. Right, so see this example, if motion is in straight line without change in direction, then distance is equal to magnitude of displacement. So for example, when you are talking about displacement, displacement is a vector quantity, distance is a scalar quantity. Right, what is the difference between scalar and vector quantity?
Scalar and vector.
Yeah.
So vector means it considers both the distance and direction, and scalar is only for direction.
Scalar has only magnitude and no direction.
Yeah.
Right, when we talk about vector quantity, it has magnitude as well as direction. Right, so can you give me one example of scalar quantity?
So distance.
Yeah, distance, anything other than distance?
Speed.
Yeah. Right, so say anything that is not related to this topic. Say is force. Is force a scalar or a vector?
I think vector.
Yeah, force is a vector. What about work?
Work is scalar.
Yeah. So work is a scalar quantity because we are not talking about any direction. Right, and this concept becomes important when we are talking about conservative and non-conservative forces. Right, so if you have studied conservative and non-conservative forces, so for example, if you talk about gravity, right, so gravity only depends on the initial and the final height. So the potential energy, change in potential energy. So say this is a building, so this is H1 and this is H2. So if an object moves from here to here, change in potential energy will be mg h1 minus mg h2. Right, no matter if the object moves like this or like this. Right, so it does not depend on the path which the object has to take to move here. The change in potential energy is always going to be mg h1 minus mg h2. However, when you take frictional force as an example, if the object moves from A to B, it means it will lose less energy because of friction. Here it will lose more energy because it is in contact with the ground for a longer period of time. Right, so conservative force like gravity are path independent, whereas non-conservative forces like friction are dependent on path. So if the motion is in straight line without change in direction, then distance is equal to mod of displacement. Why? Because as you mentioned, displacement is a vector quantity, so vector quantity has magnitude as well as direction. So we are taking mod because, say, if you are moving to the left of the origin, so distance is positive, distance is always going to be positive, displacement is negative, right? So magnitude of displacement is equal to distance in that case, right? So for all other cases, distance is always greater than displacement. So that is why this condition holds. Distance is always greater than or equal to displacement. This equal to happens when the object is moving in a straight line without changing direction, right? Now you know distance is a vector quantity, displacement, right? So see, any object, it can be located in the 3D space, right? So say for example, this is the frame of reference, which is the Cartesian system. So we have this origin. So this is the uh, most basic frame of reference, and we use it most of the time, right, in determining the position, velocity, anything. Now this is the object. This object moves from A to B. So when the object is at A, what I can do, I can calculate the distance of A from the x-axis, I can calculate the distance of A from y, I can calculate the distance of A from z. So this is the position x, y, z, okay, of this object when it is at A. And we, since this is a vector quantity, displacement is a vector quantity, we use a vector to represent the position of A, and this is known as a position vector. It is useful when we are interested in finding the displacement. Okay, so RA, it is known as the position vector. So for example, what do we do to determine RA? We just draw a straight line from the origin to the position of the object. So R means the position, A means the location of that object. So RA is the position vector for A. Now this object moved from A to B. Now the location of B is x2, y2, z2. Right, so RB is the position vector for B. Okay. How do we write RA? I mean, we cannot just write RA. It has to have some value, right? What is this equal to? So if you look at this, RA, right? So it is, so what is the x coordinate, what is the y coordinate, and what is the z coordinate? So we use I cap to denote the x coordinate, j cap to denote the y coordinate, and k cap to denote the z coordinate. Have you studied these? Okay. Similarly, RB would be x2 I cap plus y2 j cap plus z2 k cap. So what is the displacement? Initial minus final position, right? So just like we do for a motion in straight line. So an object was at 5 meter, right, say in the north, it then moved to 10 meter in the same direction. Find the displacement. So it will be 10 minus 5, right?
Yeah.
So final minus initial. Similarly, if we have to find the displacement, it would be final position vector minus initial position vector. So x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Okay. Any doubt?
Yes.
So one more thing. Can you tell me what is the distance of this object A from the origin? So we use that to denote our magnitude.
So we will have to use the distance formula.
Yeah.
Okay, so it's like x1 upon y1
x1 upon,
actually forward that.
okay, so it is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square.
Okay.
Right, so if you use that formula, what do we get?
So we don't have values of x2 of any of them.
Yeah, so you have to tell me in terms of x1, so these are variables. So you have to tell me in terms of these variables. Say let this be A, this be B, and this be C.
Yeah. So it will be a square minus. So x2 we will take, right? Because we take in both the directions.
Yeah, but we have to find the position vector for A only. Currently, we are not interested in the displacement.
Okay. So x1 is a,
So
right?
I'll give you one simple example or a simple question. So this is this is the y-axis, this is the x-axis, okay, and this is one point, say A. Okay, it is located at x1 comma y1. Will not go into 3D. No. So this is RA, the position vector of A, right? This is origin. So the question is, so I'll write RA as x1 I cap if I have to write it in terms of vector form, right? Plus y1 j cap. This is the value. Now you know this is a vector quantity, right? The position is a vector quantity. Now how will you find the two things? First is the magnitude. So magnitude we write as RA, like this. So this is the magnitude. And direction you can write in terms of tan theta. So say what is theta? Because origin is your reference point, so what angle is it making?
So it's we have to find it out.
Yeah. In terms of, because you are only given x1 and y1, how will you find that out?
Angle, right?
Both angle and magnitude. So we want two things. First is the magnitude and direction, because this is a vector, right? How will you find magnitude and direction? So this is the first question that you should be doing in vectors. So I'll tell you what RA is. So magnitude means the distance between these two points, right? So this is the magnitude and this is the direction.
Yeah. So, sir, you're not audible.
Am I audible now? Puneet, can you hear me now?
Sir, you're not audible.
Can you hear me now, Puneet?
Yes, sir.
Okay. So I'm saying that this is your RA. So this distance is magnitude of RA and this is the direction.
Yeah.
So what will be the value of this in terms of x1, y1, and what will be the value of this theta in terms of x1, y1?
So no idea. I actually studied long term. So I
Okay.
don't really.
So see, you have to just calculate the distance between A and O. Right, so your A is x1, y1. What is O? What is the coordinate of O?
0, 0.
0, 0. Right, so distance between these two will be x1 minus 0 whole square, which is x1 whole square, plus y1 minus 0 whole square, which is y1 whole square, root over.
Yes.
This is the magnitude of this vector, position vector. Direction means theta. How do we find theta? You can draw a triangle like this. So this is a right angle triangle. So what is this distance from here to here?
Yes.
Yeah, so what is the value?
So in terms of trigonometry,
Not in terms of trigonometry, say x1, y1. This is the point. If I draw a perpendicular like this, so what will this distance be? Will this
like
be x1? Why? Because this point is located at a distance of x1 from the x-axis. So if I drop a line, it will give me the distance.
okay. Yes.
Similarly, can you tell me what will be the this value?
5.
y1, correct. So I can calculate tan theta. So tan theta will be y1 upon x1. Right, so if I find the value of y1 upon x1, say if this is root 3, theta will be 60. So this is how I estimate the value. So if I have a vector quantity and I have to find the magnitude, I can find the magnitude like this. So if you are given a vector quantity like this, and you're asked to find the magnitude and direction, you'll use this to find the magnitude of the vector quantity, and you'll use this to find the direction of the vector quantity, given that your frame of reference is the origin.
Yes.
Is this clear?
Yes.
So this is the first question. A particle goes along a quadrant from A to B of a circle of radius 10 meter as shown in figure. Find the direction and magnitude of displacement and distance along the path AB. Right. So here the starting point is A, the ending point is B. Right. What will you do? First of all, find the position vectors. So RA. What will be the value of RA?
So where's R?
At this point. Right. This is the starting point.
Yeah.
So RA will be this point for this vector.
Okay. So I cap is like the value of OA.
Yeah, I cap means it is in the x-axis. Okay.
And J cap will be 0.
Yeah. So how much I cap? OA, right? So it says circle of radius 10. So this distance must be 10.
10 I.
Yeah. So we'll not write J cap because it is 0.
And K is also.
Yeah. What about RB?
Yeah, so I cap is 0 and J cap is 10.
So 10 J cap. Right. So you'll let me just write this as vector. So displacement. What is the displacement? Delta R. What will be the value of this?
will take 10 common, then I cap minus j.
10 comma 10.
No, I mean 10 will be common term.
Yeah. So, I mean, in this term, you'll write RB minus RA, right? Final minus initial. So, RB minus RA. Okay, so this is RB is 10 J cap minus 10 I cap. Right, so this is the position vector, I mean, this is the displacement of this particle. Is this clear?
Yes.
Now you have to find the magnitude and direction. Okay, so to find the magnitude, so what will be the magnitude of this displacement?
So displacement will be the hypotenuse, like AAB.
Yeah. So, I mean, once you have calculated this, you can find easily. Right, so it will be root over 10 square plus 10 square or 10 root 2.
So sir, are these I cap and j cap having values?
No, they don't have any value. So this just means, so see, you cannot add the value. So this is just the coordinate system that you are writing. So in other words, I can write this as minus 10 comma 10. So this is a way to write it. Right, so it makes simplification, I mean, solving two vectors, solving problems with two or more vectors easily. So if you have to add three vectors, using this method, you can solve it easily. If you just write it in terms of coordinate system.
Yes.
Right. So if you have to find the magnitude, what will be the magnitude? 10 root 2, because root over 10 square plus 10 square. Right. What about the direction?
Towards the
So see, when y is equal to x, tan 45 is 1. I mean, theta is 1, tan theta is 1, right? So theta must be 45. But here you should look at this point, minus 10 comma 10. What quadrant is it lying? First, second, third, or fourth?
third, no, second.
Yeah, so it will lie here. Right, so here if you plot minus 10 and 10, so it will be somewhere around here. Right, so from the origin, what is the angle that it makes?
Okay, so theta plus 90 degree.
Yeah, correct. So whatever angle you are getting, just add 90 degree. So theta will be 145.
Yeah.
Right, now if you have studied addition of vectors, right, so what is it doing? So this is OB, right, so this is OB and this is OA. What we did is we subtracted it like this, B minus A, right, RB minus RA. What it is doing is, it is using vector to subtract. Right, so this is your OB, right, and this is your OA. So you have to do OB minus OA because final minus initial. Right, so if this is OA, what will be minus OA? I mean, have you studied this? If you have to subtract A minus B, two vectors, what you do, you do A plus minus B.
Yeah.
Right, and there is a rule for addition of vectors. So if this is the first vector, so this is the first vector, like this. This is the second vector. And if you are adding these two vectors, right? So find a vector that closes this loop. So if it goes like this goes like this. So you have to find a vector. So if you have to close this loop, it will go like this, right?
Yeah, and if it's a closed loop, so the sum will be 0.
Yeah. So you don't have to close this loop. So first find a vector that closes this loop, which is this one, right?
Yes.
So you have to do the opposite, this one. So this vector is the sum of this and this.
Yeah.
Right. So here what you do is you have OA, you have OB. Now you have to subtract both of these, right? OB minus OA. So instead of subtracting, what you do, you take minus of OA and then add it. So this is OB.
So
OA was here,
suppose
right? Yeah, go ahead.
it will be OC, right? Like,
Yeah, this one.
yeah.
Right. So you had OB. If you had to write OA, so you OA would be this, right? Like this. So you take minus OA, which is the mirror image. So minus OA comes here. Now you add both of this. So you find a vector that closes this loop, then the opposite of that. Right, so this is the difference. Now you see the same thing we calculated along with the position as well. Right, so if you use this one, I mean this rule, then you don't have to draw this diagram as well. But I mean, knowing the diagram is also important. Okay, so I mean, you can just determine the position vector. Based on the position vector, you can tell the quadrant wherein it lies. And if it lies in the third quadrant, you'll add 180 degree to the theta. If it lies in the fourth quadrant, you'll add 270 to the theta. If it is in the first quadrant, it will be theta. Okay, now, I mean, if you have to find the distance traveled, so it will be just this particular distance, right? Which is 1/4 of 2 pi r. Okay. So this is what they have done. So 1/4 of 2 pi r. Okay. Any doubt?
No, sir.
On an open ground, a motorist follows a track that turns to his left by an angle of 60 degree after every 500 meter. Starting from a given turn, specify the displacement of the motorist at the third, sixth, and eighth turn. Compare the magnitude of displacement with the total path length covered by the motorist in each case. So what is this question saying? There's a motorist, say it starts from this point, right? Now it moves 500 meter and then turns 60 degree to his left. So if you travel in this path, this will be your left, right? So you travel for 500 meter, turn left, then you travel for 500 meter again, then turn left 60 degrees, then you travel 500 meter again, turn left 60 degrees. So you are making 60 degree every time, right?
Yeah.
Now starting from a given turn, specify the displacement of the motorist at the third. So first we'll look at third, right? So this is the third,
Yes.
right? So third, sixth, and eighth turn. So first of all, you started from here, and this is the third turn, right?
Yeah.
So you have to find the displacement, which is the shortest path. So you join these 2 points, O and C. So this, I mean, all the sides are the same.
Yeah.
Right, and what is this figure? So exterior angle is 60 degree, right? The exterior angle is 60 degrees. So what can be this figure? And all sides are equal as well.
So can you repeat?
So this exterior angle, it is 60 degree. Or you can say interior angle is, what is the value of interior angle? 120. Right? And all sides are the same.
Yes.
So what can be this figure?
Hexagon.
Yeah.
Regular hexagon.
Yeah. So all sides are equal. So you just have to find this distance. Because here you are not interested in finding the direction, the position, anything, the vector. Just interested in finding this particular distance and the displacement. So this is the displacement, this is the distance. So distance is 500 plus 500 plus 500, 1500. So this is the distance. Now you just need to find the displacement from here to here. What is the length? So this just needs some knowledge of geometry. Right? You don't have to solve anything in vector form. So see, this is a hexagon and this is just like a diagonal of a hexagon.
Yeah.
Right? So if you take this part, you can divide it into how many triangles? Two triangles and then one rectangle, you can say. Right?
Yeah.
So if this is 500, this is also going to be 500.
Yes.
Because these two are parallel, and then you have drawn these lines perpendicular. So this becomes a rectangle. So this is 500, this is also 500. Now, if this is 500, can you find the value of this? Would it be possible to find the value of this if this is 500?
So we would need the third side.
No, so because you are given the angle and you know trigonometry.
Yes.
So,
So for 60 then it will be half.
yeah. So this
So
becomes, very good. So this becomes 250. What about this?
it's 250.
250. So displacement becomes 250 plus 250, which is 500, 500 plus 500, which is 1000. Right, so you have to compare the distance and displacement. So it is 2 by 3. So 1000 by 1500. Right, now we are done with the third position. Now we have the sixth position. So first, I mean, this is the first turn, this is the second, third, fourth, fifth, sixth. So at the sixth turn, you will be starting at the initial point. So what is the displacement here?
Uh, 0.
0. What will be the distance?
3000.
3000. So it will be 0 by 3000. Right?
Yes.
Now the cycle is going to repeat after 6. So this will be 7th also. So first will be 7th and then second will be 8th. Now you have the same hexagon. Now you just, the line that joins these two changes. Like this. Right, so if this is 60, since hexagon, this is a regular hexagon, so if you take half of that, it will be 30, the angle. Right? So both angles will be 30, you just have to draw up a perpendicular like this. Now if you just find one of them, you just have to multiply that by 2. Right, so can you find this value, this length? This is 30, this is 500. Can you tell me the value of this?
Yes. So we will take cos here. So 2 3 by 2.
Yeah.
So x upon 500 will be 50.
Yeah, so x will be
500 rupees upon 250.
yeah. So see, most of the time, so we call this as a projection.
Yes.
So this projection is, so if you know the hypotenuse, you have to find this one that is touching the angle. So it will be 500 cos 30. If you have to find this one which has no relation, which is not adjacent or not touching this angle, it will be 500 sin 30. Okay, so because we use this repeatedly, we can just remember this. So So you must have studied force and distance, right? So force and distance. This is the force and this is the distance this object is moving. Okay?
Yes.
And this is 30. So work done is F S cos 30, right? Why? Because if you look at this projection of F, it will be F cos 30. Right? And in the y direction it will be F sin 30. But you know in the y direction there is no displacement. So y direction work done is 0. X direction it will be force in the x direction, which is F cos 30 times S. Okay? So this is 500 root 3 by 2. This is also 500 root 3 by 2. So you just multiply this with 2. Right? So the answer becomes 500 root 3. 500 root 3 is the displacement. Right? And what is the distance here? Is it 1000?
Yes.
No, it is not 1000 because he made a full circle first. So you should add the remaining distances as well.
Okay.
Right? So the remaining 3000 plus 1000, which is 4000. Okay, any doubt?
Yes.
A drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward, followed again by 5 steps forward and 3 steps backward, and so on. Each step is 1 meter long as required, 1 meter long and requires 1 second. Plot the xt time graph of his motion. Determine graphically or otherwise how long the drunkard takes to fall in the pit 9 meter away from the start. So here, I mean, you are given this, but we'll draw this because we are required to find. So he takes 5 steps forward and 3 steps backward. Each step is 1 meter long and takes 1 second. Right, so it is easy to draw the xt graph. So where should we write x? In the x-axis or in the y-axis?
Yes.
See, most of the time we write t in the x-axis, right? Because it is easier to track the displacement in that case. So this is x. X means distance. It can also be y, right? So to show the progression of time, we represent time in the x-axis. Otherwise, it will be difficult to interpret what the figure is trying to convey. Okay, most of the graphs that you see, you'll always see time in the x-axis,
Yes.
right? So he takes 5 step forward. 5 step means 5 meter. Right? So see, this is 1 comma 1, this is 2 comma 2, this is 3 comma 3, this is 4 comma 4, and this is 5 comma 5. Because if x is moving or x is increasing, time is also increasing, right?
Yes.
So the first 5 steps will look like this, right?
And then it will come down.
Yeah. So now it will be 4 comma 6.
3 comma 6.
Yeah. So I'll just write this. This is 5, right? And this is 5. Now this is 4 comma 6 and this is 3 comma 7 and this is,
So now it will go up.
so it was 2 steps backward. Okay. So this becomes, time becomes 7 here, right?
Can you check again if it was 2 or 3?
Okay, it is 3. So we'll just extend this till here. Right, so it will be, time is now 8, right? And distance has reduced to 2. Now in the subsequent step, he'll move 5 steps more. So this is 2, 2 plus 5 becomes 7. Right, so this is 7. So this point is 7 now. And what about this? So this will be 8 plus 7, which is 15. Sorry, yeah, 8 plus 7 is 8 plus
Right.
5, right? So this point is 30. Now again 3 steps backward, so 3 steps down. So now this will become 7 minus 3, which is 4 now. Right, I think it should be below, but yeah, no problem. We'll just, this is just for the sake of understanding. So this will be 4, right? And then 13 plus 3 will be 16. Now he'll move 5 steps more. So now 4 plus 5 gives you 9. Right, so the pit was 9 meter away. Right, so if you add 16 plus 5, it will become 21. Right, so this is how we solve this graphically. Other way is, so 5 steps forward and 3 steps backward.
So 8 meters, no, 2 meters in 8 seconds.
Yeah, so 2 meters in 8 seconds.
Yeah, so average speed is for 1 meter it takes 4 seconds.
Yeah,
So for 9 meters it should take 4 times 9, but it's wrong.
yeah, so because here you are counting forward and backward both at the same time.
Yes.
Right, so the last step should only count for the forward move. Right, so see what happens is 2 steps in the forward direction in 8 seconds. So 2 meter in 8 seconds. Right? Then 4 meter in 16 seconds.
Yes.
Right, now if you further calculate this, this will become 6 meter in 24 seconds, but that is incorrect because you have already moved forward and then now you are coming back from there. Because see what we are doing wrong here is, so we already reached the pit 9 meter. Now if we again go 3 steps back, so it will be again at 6 meter.
Yes.
Right, so we don't have to count in the last step, we don't have to count the backward step. So 2 meter in the first 8 seconds, 4 meter in 16 seconds. Now if we just go forward, which is 5 meter, he'll fall in the pit, which is 9 meter. 9 meter in 21 seconds.
Yes.
Okay. So see, when you are given a very large distance, so you just have to reach the point and then go 1 step back. How do you reach that point? So first of all, find the location of the pit. This is 9 meter, right? Subtract the distance in forward step, 5 meter. So this is the point wherein this method is going to work. Just divide it. So just divide this by 2 meters. So 2 intervals. So 2 times 8, which is 60.
Okay.
Any doubt? Okay. So then you have two concepts: average rate of change and instantaneous. So average velocity versus instantaneous velocity. What is the difference?
So instantaneous is like for that very moment, and average is for a huge period of time.
Yeah, very good. So when you are looking at a longer period, so it is all about the time interval. If the time interval is very large, right? So we are interested in average. If the time interval is very small, so we want to see how much the distance has changed in this very small time period. So if you can, so say for example, this is a large time period. You keep on reducing, keep on reducing, keep on reducing until you reach a very small scale. That is known as dt. Right, so there is a difference between delta and d.
Yes.
Delta means large, d means very small. Right, so again there are two terms: infinite. Infinite means very large. Infinitesimal means infinitely small, just like 1 upon infinity. This is very small number, right? Very close to 0. So this is what we mean by d, and delta means very large. Okay, so when you are calculating average of anything, say average speed, what you'll do, you'll find
Yes.
total distance upon total time taken, right? So for example, rate of change of anything, so this is equal to change in y upon change in x, which is delta y upon delta x, because the distance is very large. So currently it is applicable to anything. Later we'll see what happens when time is in the x-axis. So when is in the x-axis, this is, what does this become? This becomes average velocity or average speed. Right, so average speed will become change in y upon change in time. Right, so usually what happens is y1 is 0, because when we are starting with the initial point, our starting point is 0, and x1 is also 0. So if I have to write this in terms of time, so it will be y2 minus y1 upon t2 minus t1, right? So as I mentioned, whenever we are solving such problems, y1 starting point is 0 and starting time is also 0, because we always start at t equals to 0. So this becomes y2 upon t2. So this y2 means the total distance traveled, and t2 means the total time taken. So this is just a simplification. Sometimes we may be starting at t equals to 2. So this is a more generic case that covers everything. Okay. So this is equal to y2 minus y1 upon x2 minus x1. Here instantaneous means dy upon dx. Okay, and at very moment, so see this instantaneous change, the slope also changes instantaneously. At every point the slope is different.
Yes.
So you already know y by x is tan theta, right? So this dy by dx will also be equal to tan theta at that point. So if you want to calculate the instantaneous change at this point, you'll calculate the slope and you'll be able to find. Right, so the only difference is I'm just looking at this very small point. At this very instant, say just 1 millisecond before, my speed was this, and now my speed has changed to this. So this is what you mean by dy by dx. Okay, now see, you can write the dy by dx in terms of delta y by delta x. So when this delta x is very small, right? So that is what it means, limit. So you're limiting delta x to 0, right? So when your delta x is 0, your average becomes instantaneous. Okay, and I mean, when you study limits, then we'll see this. What does this mean? Okay,
Yes.
so what it basically means is, what is f of x plus delta x? It is just y, right? So this is y2 minus y1 upon x2 minus x1, right? Because see, y can be x square, right? So what does f of x plus delta x? So x was my initial point. Say x, my initial point is a. My final point is a plus 2. So this is x. So this is x1 and this is x2. So it will be, say, a plus 2, my final point. So this is your delta x, right? Now my y is going to change based on x, right? Because y is x square. So at this point y will be a square. And at this point it will be a plus 2 whole square. Right, so this is what it is meaning. I am just substituting the new x in the value of y. So this is what you mean by f of x plus delta x minus f of x divided by delta x. So I am doing y2 minus y1 upon x2 minus x1 and limiting my x to 0 because I am trying to make that x very, very small.
Yes.
Right, so the branch of mathematics that deals with this, what is that known as?
Sir, differentiation.
Yeah, it is known as calculus.
Okay.
Right, because it includes integration as well. Right, so when you have very small quantities and you are trying to solve it, so because you cannot zoom into this picture and then find that very small length and then calculate what is the change in y. Right, so you need mathematics to solve this. Right, so say if I give you sine, right, you have to find the value of, say, so see, y is sine x, right? If I ask you to find the value of dy by dx, okay, at x is equal to 0. Without calculus, what you'll do, you'll take first x is 0, then you'll take another value, x is 0.000000, say 1000 ones, 1000 zeros and then ones, very small value, right? Now you'll find the value of sine of 0. Sine of 0 is 0. Right, now what is the value of this? It is difficult to find.
So we just take it as 0.
We just take it as
0.
no. You cannot take this as 0. So see, I've taught you this previously. If you look at the graph of sine x, it is like this, right? What happens when x is very, very small?
It is close to 0. Sine of x.
No. So when x is very, very small, sine x behaves as x. If you just look at this very small portion, just close to the origin, it is just like a straight line. Right, this thing. It is just like a straight line, right? Like y is equal to x. right? So these things we should know in order to solve such questions. So there is a chapter on limit, so that deals with all these knowledge. So I mean that is also a very important topic from JEE perspective, right? So sine of 0 is 0. Sine of this will be this itself, this number itself, because sine of very small number or sine of x when x is very small is x itself, right? So if you write 0 minus k, let that small number be k, right? I just assume this as k. So sine of k, what will be the value of sine of k? It will be k, right? Because that is
So,
very small. So I'm trying to write y2 minus y1 upon x2 minus x1, right? So y2 is sine of k, which is k, right? Y1 is 0, right? What is x2?
so x2. Sir, is that the distance?
No, this is slope. So this is dy by dx, right? Now what I have done, I'm calculating dy by dx by ensuring that this dx is very, very small. So that is how I've chosen my x2 and x1. Otherwise it would have been, if I take x2 x I, if I take x as 0, right? So x1 as 0 and x2 as 10, then this will be delta y by delta x and not dy by dx, right? So I calculated y2, which is k. I calculated y1, which is sine 0, which is 0, right?
Yes.
So what will be the denominator? x2. What will be the value of x2?
Sine of it, because it's very small.
No, x2. See, this is x1 and this is x2. x2 is the value in my hand.
Yeah. Okay. So the small one, very small.
Yeah, k,
K.
right?
Yes.
What is x1?
X1 is 0.
0. So k minus 0 upon k minus 0. What is the value? 1. Right? So dy by dx at x equals to 0 is 1 for sine x. Right? So do you know what is the differentiation of sine x? If you have studied differentiation,
Yes.
it is cos x
Okay. So for cos x, it will be sine.
minus sine x. Right? So see, now if from calculus I know this, d sine x by dx is cos x. Okay, now if I ask what is d sine x by dx at x equals to 0, so I know d sine x by dx is cos x, so I just substitute cos 0. So it will give me 1. Right? So I mean this tedious calculation I'm avoiding. Right? Although someone who has derived this must have gone through this tedious calculation first. Right? And this kind of understanding is very important. So when you study that topic on limits, so we'll first see how do we find dy by dx of different functions, x square, x cube, right? How do we solve or how do we derive the dy by dx? For example, x square, dy by dx of x square, what is the value? 2x. So how is this equal to 2x? We'll see.
So that was a formula.
So it is just, see, y2 minus y1 upon x2 minus x1. This is the formula and nothing else. Now x2 minus x1 should be in your hand, right? So x1 you can, so let x1 be x, right? So x2 will be x plus dx. right? So y2, or say what will be the value of y1? Y1 will be x square, right?
Yes.
Y2 will be x plus dx whole square. Right, because I have to just substitute, in place of x, I have to substitute x plus dx. Right. So now if you simplify this, you'll get x square plus dx whole square plus 2x dx. Right.
Yes.
Now if you calculate y2 minus y1, what will be the value?
So it will be dx whole square plus 2x dx.
Upon, what is x2 minus x1?
So it's in our hand.
Yeah, so you know the value of x2, x plus dx, and you know the value of x1, which is x. So what will be the value if you take their differences?
Dx minus x.
So x plus dx minus x, right? So
Yes.
this will be
So
equal to dx. Now see, dx is very small, right? So what about the square of that very small number?
even small.
Yeah, so we can just ignore this, very close to 0. We cannot ignore dx, but we can ignore its square, right? So we'll be left with 2x dx upon dx. So dx gets cancelled, you are left with 2x. So this is how you get the differentiation of x square.
Yeah.
Okay. So next class what we'll do is, again, we have topics on differentiation and integration, which is the foundation for this. So I think you have already studied. We'll just revisit these differentiation concepts and then how it helps us to solve questions in kinematics. So kinematics is more of mathematics, right? So you'll be given equations on velocity, and you'll be told to find what is the maximum velocity. So you'll be given an equation for velocity. Let me show you a question. Yeah, like this. So velocity of particle is related to its displacement at this. Calculate acceleration at this point. So here we have to use differentiation. We'll see how. Okay. Any
Yes.
question so far?
Yes.
Okay, fine. We'll connect again in the next class.